Hello and welcome to Epic Home Tech. I'm Jeremy and my co-host Jared,
Hello?
and we're going to go ahead and we're going to do a Juniper lab. We're going to do some Juniper basic configuration. Two devices talking to each other, basic configuration, firewalls, and basic interface. So today we're using GNS3 on an Ubuntu 2004 machine. This is the VSRX 3 images. If you're looking around for the VSRX templates, definitely hit the VSRX 3. The performance is significantly better. They start up so much faster. We're going to be setting up a couple of interfaces, getting the two devices to talk. You can see in my canvas here that I've already got the devices laid out. I drew a connection, a wire between the two to each of their GE000 interfaces. And here are the IP spaces we're going to be using today. So if you're using Ubuntu in your future setups, make sure you change your configuration. Bring it down to 3072 meg for your memory. The 4 gig that it comes default is unnecessary, but it won't run with less than 3. And you'll want to make sure that your network is not the VMXNet 3 if you're running this on Ubuntu. The VMXNet 3 chokes at some point with a MTU reconfiguration. So switch it to the VirtIO Net PCI and everything will work swimmingly.
What's the Jeremy, what's the normal boot up time on the Junipers? Just is it usually 15-20 minutes on the average, or what are most users going to experience?
On the VSRX 3, it's between 10 and 15 minutes, not typically longer than that. On the non 3 version, I haven't chased down all of the details specifically of what they're called, but on the non 3 version, it can take up to 45 minutes. Some of the early VSRX images for AWS would take 45 minutes to an hour. It was horrendously painful. And the shitty part is that when you're spinning this up in AWS, you're paying by the hour. So you just spent an hour to spin this thing up. And typically after first boot on those earlier images, it wouldn't load the data plane. So the interfaces wouldn't come up. You'd have to then reboot it after it booted up the first time. And then the interfaces would come up. So you are now in between an hour and a half and 2 hours of expenditures, and you still haven't passed a single packet.
Wow, that's good information to know. You know, somebody sends somebody to a site, maybe just to reboot a device, or have a customer on the other end reboot it. You know what they can expect maybe before they can see a device come on. It's not necessarily a
Absolutely.
failure if you don't see something in 20 minutes. So.
Absolutely. Especially in AWS where you don't have the console to look at or it's very inconvenient to access. Nobody wants to have to sit there wondering whether or not this thing is going to come up, and that's where I was when I first started up the VSRXs. Is this thing even working? It's still not coming online. And then I'd reboot the thing again, and then the timer starts again. So it probably took me, I don't know, the better part of a day to just get the thing booted up so I could actually do something with it. And the AWS instance is weird as well. So the AWS VSRX, the AWS recognized ETH0 interface maps to the VSRX FXP0 interface, which is management only. FXP0 is management only on all of the Juniper devices that have an FXP0. Not all devices have an FXP0, I don't believe, but on the AWS VSRX ETH0 in AWS, the first interface for the EC2 instance is FXP0. Your first revenue port, the first port for actually passing the intended traffic, is ETH. I think it's 2. It's either ETH0 or 1, or 1 and 2. I don't remember if AWS counts them starting from 0 if it's 0 based, but regardless, the first interface is FXP0. The second interface is your first revenue. So if you wanted to have this as like a border router where you have one interface facing the internet, one interface facing the internal, you would need 3 interfaces provisioned on the Juniper VSRX and AWS. which is also the limitation of why the VSRX minimum size is a medium. You can't get smaller than a medium and have 3 interfaces.
Okay. Okay.
So,
Yeah, I remember my first experience with it. You know, I put it in, get everything fired up, and it was shockingly long compared to what I had experienced
yeah.
for a boot up process.
Yeah,
So,
it does take a
but
while. What is interesting though is
stable.
if you have some of the bigger devices like the MXs and some of the larger chassis SRXs, the routing engine boots up very quickly, but if you're sitting on the console and you're watching, it takes probably about another 5 to 10 minutes for the entire data plane to finish booting up. So you'll actually have a login prompt, but you won't have any interfaces until the data plane finishes booting up and all the cards are ready. Um,
Oh,
so,
okay.
all right, so our SRX is booted up. So we're going to log in with root and the default for all new versions of Juniper devices. Older versions had a password. Newer versions, vanilla, come without a password. The exception being the VSRX in AWS. That one you have to actually log in with an SSH key. There are no other boot options unless you do the user data. But that's way out of scope of this conversation. Now we're getting into cloud init shit. And
Gotcha.
all right, so we logged in, root, no password. And it brings us to a BSD shell. So we type CLI to get us into the Junos CLI. All right, so here we can go show hardware, sorry, show chassis hardware, and we can see that we've got all of our stuff. So here's our FPC, and we have our PIC, and you'll see this is DPDK, and you can definitely go ahead and Google that. But that is a accelerated kernel level packet processing engine. It is wicked fast, and I'm very impressed and pleased to see that they have it loaded in here. You also see that it has GE next to it, so this is recognizing that it is set for gigabit interfaces. However, I don't think that's a hard and fast thing. So
Sure. And every Juniper device, you know, when you log in with that root, you know, you know, at least for my experience, you know, and you is you're not going to be able to commit a single thing until you at least um, create what is that? Create a password or plain text password for the
yep,
device, right?
yep, the road authentication password.
Yep.
So that'll be next. That'll be next. We're getting there. We're getting there.
Nice.
Jumping the gun. Jumping the gun. All right. So here's our device. For future, if you're spinning up your devices, show chassis hardware will show you all of your equipment. We'll show you the device. We'll show you any pluggables that you've got, any SFPs, SFP pluses, 40 gig, 100 gig. But it also tells you the serial number here, and you always go with the chassis number. So here's chassis, the serial number. So if you ever have to go and deal with JTAG or register the device, it will always be the chassis serial number. Some of the other removable parts, the pluggables or line cards, are going to have their own serial numbers. But whenever you're dealing with support or registrations, always go with the chassis number.
Okay.
If these were a virtual chassis setup, a cluster, you would see both devices, and that's where licensing starts getting a little bit more complicated because you have to license both of them. So, all right, that's out of scope. So let's go ahead and let's get this config started here. So first thing we're going to do is we're going to do a load override terminal, and we're just going to mash enter a couple of times and Control D to save. And we have no configuration, so we just cleaned everything out. There is a default configuration, but we're not going to use it because using the defaults, that's no fun. Let's turn down the music just a hair. Last time was a little loud. Oh shit, now it might be too quiet. Just can't win. I think I was playing with it in the middle of the fade out of a song.
Now the default config that comes in there, I mean, in its most basic form, what can you really do with it? anything, or just it'll just at least have a security zone in there for someone that maybe just wants to edit something real quick and get something on, or um,
Good
is it always
question.
just
Let's check. So the default configuration. So they've got your basic system configs. So this is auto installation. So this will do DHCP booting, and it's Juniper calls their process auto install, but it's basically a what is it? Zero touch configuration. So it'll span out for DHCP, look for configurations. We've got basic services, SSH, and this is their JWeb. I don't use JWeb. I don't like it. You're welcome to, develop your own opinion, but it's not very popular. Most people that are going to be using Juniper devices are either going to be using the CLI, or with the SRXs, you're going to be using Security Director or any of their other bigger softwares for management of the devices. Basic syslog configurations and license auto updates. So if you've got your device registered, this will pull the licensing for it, so you can get all of your licensing. This is also telling us that we don't have our root authentication, so we need to get our root authentication together eventually. So we will get to that. So here's basic interface screening. So we've got ICMP ping of death. I would love to find a device that's still vulnerable to some of these things, like teardrop. SIM floods are probably still legit. So some basic security policies as well. So in a zone-based firewall, everything that you do that's going to be related to the security pieces are going to be related to traffic that's going to be going from a zone to a zone. So it can either be the same zone, it can be different zones, but it will always be zone to zone traffic.
okay?
So here we have a trust to trust zone, and we have a trust to untrust zones. And we'll see those definitions later as we move a little bit further through the config. Pre-ID default policy. That one I've never seen.
Yeah, I don't recognize that either.
Through the Google machine. Pre-ID default policy. Description. During the initial policy lookup phase, which occurs prior to a dynamic application being identified, if there are multiple policies present in the potential policy list, the SRX series device applies the default security policy until a more explicit match has occurred. Oh, this is more related to the app ID pieces. So this is their IDS IPS functionality. So until a application has been identified, this will be the policy that's applied to it. So
Okay.
we haven't recognized this traffic, so we're going to apply this policy until we do recognize the traffic. So you could set it up to like a fail secure type of thing. I don't recognize the traffic, so I'm going to terminate it. But that could lead to scenarios where you can't properly identify the traffic, right? So if this is like a TCP handshake or some sort of deeper behavioral recognition, then you'll want to have a behavior to recognize. So you need to permit the traffic to establish that behavior. But I guess it all depends on what you're looking for and which direction you're going to be processing this. I would assume that you can have different default policies based on directionality, but I'm not 100% on that. This is new to me. I haven't done very much with the IDS IPS functionality. It's something that I definitely need to shore up, and if anybody's interested in seeing those types of configurations, just go ahead and leave a comment and we'll see what we can do. So, pre-ID default. So zones, here are the zone configurations, the zone specifications. So these define the zones: security zone trust, security zone untrust. and you see that those are associated here. So we create the zones and then the policies for them and the traffic to go between. There is no implicit allow for traffic within zones. So if you have multiple interfaces in the same zone, unless you create a same zone to same zone kind of configuration, traffic will not pass. And here we see FXP0. So there you go. There's the default configuration. That's the default configuration
Gotcha.
for a VSRX. Since a VSRX is not an edge firewall in and of itself, it's not a piece of equipment, it's not an appliance you set down, this configuration is relatively simplistic. Also, since it is a VSRX, you don't know what interfaces are attached by default, so they don't have any interfaces in this other than FXP0. So you could have 8 interfaces, but as a default configuration, none of those are known. If this were
Sure.
a SRX 300 or an SRX 345, you would have a default configuration that looks more like a Soho type of config, a very simple one-WAN interface, LAN interfaces, NAT, firewalling, zone-based firewalls, very simple plug-in, get up and go type of configuration. But
Sure, and
that
it's
type
nice that
of
there is like a little default config in there, but unless you're really solid on what you're doing or paying attention to what is in there, I mean, it seems like it could really bite you too, just by having
absolutely.
something in there that you weren't expecting or didn't even notice was there, as i.e. something new.
Absolutely. I try to default to explicit configurations wherever possible. I try to make sure that if something is going to behave in a way that I want it to, that I will have defined it to be such. I don't like an unexpected configuration, especially when you start talking about a security appliance. If somebody leaves something in a config or it's a default config and there's default configurations that can leave your device open, like let's say it's got the web management, and you find out, in 6 months that there's a CVE on Juniper Web Management. You're like, I never turned on web management, no big deal, that doesn't apply to me. It's a remote code
Sure.
execution on unauthenticated, kind of business, but I never turned it on, so I'm safe. And then come to find out that you left the default configuration, web management is on, your device got pwned, and welcome to the walk of shame when you go back to your leadership and say, hey, our network that I said was secure, and not so much.
Sure. Yeah, and almost to that, yeah, again, having that in there, unless you're really good at either paying attention to it or, you're just going to edit this here or there, it just seems like it can open up a door that you really don't want, or a hallway that you really don't want to start walking down.
Absolutely. Absolutely. Security first, man. Security first.
Yep.
All right. So right now, our configuration is empty. Before we can do anything special or exciting, always start with your root authentication. You have to do your plain text password. Since Juniper allows you to log in without a password for root, it also forces you to have a password in your config before you can actually put it into active use. So, plain text password, and it will not show you the password on the command line. So we mash a bunch of keys and we've got a password set. So by default, Juniper will always encrypt passwords, and these are encrypted. Encrypted-ish. It's a one-way hash. It's safe for now.
Safe enough.
Safe enough. I don't think it's, quantum safe, but that's all right. There's only so much you can do, right? All right. So let's go ahead and let's finish getting this set up. All right, so we set our own authentication password interface. All right, so we're going to go ahead and set our interfaces. And the interface that we're going to configure is GE000. So this will be a gigabit Ethernet on the 0th FPC on the 0th PIC, and this will be the 0th port. And for anybody who's wondering, 0th is a real word. Google it.
I would have not guessed that.
Yeah. Zeroth is before first. So it's real.
Well,
All right, so Juniper also does their interfaces by default with a kind of sub interface. So in Cisco, they would be called sub interfaces. In Juniper, they are called units. But by default, Juniper uses units. This lines up with their philosophy of the configuration is of a standard and it is consistent. So if you have interfaces, your interfaces will always be some designator, GE, XE, or such, dash, some number, /number, /number for FPC pick and port, always and every time. If you choose to make this a stack in the day later, or you choose to make this a cluster, that interface designation will never change. In Cisco devices, if you have a cat switch and it is a standalone device right now, and then you put it into a stack, all of the interfaces get renamed. They add an additional number at the end. None of that happens with Juniper. Same with the units. They are always units. You always have a unit designator. So if this is the first and only unit and it's an untagged, no .1q interface, it will always be unit 0. There is no not unit 0 type of configuration. There is not a not sub interface type of configuration like you would have with a Cisco. Always has a unit. If you choose to add a .1q tag, then you will have a different unit ID for it. So maybe it's going to be VLAN 75. So you create unit 75 and then you put the VLAN designator on it. So always have a unit. It's different,
nice.
but it makes sense.
And I see there you have unit 0, but in the config, well, I assume it won't say unit 0. It'll just probably be 0/0/0/0.0, correct? Just for reference.
Nope, it will actually say unit
Will
0
it say
in the
unit 0?
config.
Okay.
Absolutely. In the config, it will always show unit as a full parsed out thing. The shorthand that you referred to, the .0, is what you can use when you're on the command line for the interfaces, but it will extrapolate out. So if we were to go description and we were to say a interface, and then we go show interfaces, you will see that it is unit 0 with the description.
For sure it does.
For anybody who's savvy out there, you recognize that this looks very much like JSON. It is not JSON per se. However, we can show it in JSON. And what is the command for that? Show interfaces, display JSON. Now it is JSON. So there is a difference. So JSON looks like JSON. The other configuration, this configuration here, is what Juniper calls their text configuration. So this is their text display mode. If you're going to load configuration, it is going to be loaded as what they call text. This would be loaded as JSON. And the last, which some of the older Juniper guys is their preference, is the display set. This type of display lines up more with a kind of, I started with Cisco and I was Cisco for 20 years kind of display. I don't like it. It makes it very difficult for me to see visually where we are in a configuration with all of these words that start splashing out when you've got a bigger configuration. But this is my preferred display method. Once you start getting this config out and you're going to start playing with it in an IDE, I think IDE is an integrated development environment, interpretive development environment. I might have to look that one up. But a actual software for editing software like VS Code or Atom, you'll be able to expand and collapse some of these sections so system can be collapsed, interfaces can be collapsed, and it helps you navigate your configuration a lot easier. All right, so we've got our interfaces. So we're going to go ahead and set our interfaces, GE00, unit 0. So Juniper's configurations are simply this. So you've got GE00, that's going to be your physical layer type of stuff. This is how you found the physical interface. Unit 0 will be your logical, your layer 2. Now we're going to start stepping into the bigger protocols. So we're going to go into a protocol family. And in the protocol family, we have a few different protocols. Saying layer 3 isn't exactly accurate because for anybody who knows, VPLS is the layer 2 protocol. These are both layer 2 protocols here and here. So the CCCs, the TCC, the VPLS, those are all layer 2s. ISO is a different protocol. I think that qualifies as somewhere between a 2 and a 3. Ethernet switching is obviously layer 2. This I don't believe actually applies to a VSRX. So it's not entirely layer 2 or layer 3 kind of business, but it's close enough for horseshoes and hand grenades. So the protocol family we're interested in is INET for IPv4. And then we're going to set an IP address. And our IP address is 192.168.1.1. And Juniper always does CIDR notation. That is my preference. Again,
Yeah, absolutely.
Cisco started with the dotted decimal notation, which I don't like. Some of their newer devices will accept CIDR notation. CIDR notation makes more sense once you start getting into the bigger networking and you're trying to figure out how you're going to manage subnets and understanding the bits left and right kind of translations when you start taking a larger subnet and making smaller ones of it. Once you get away from the dotted decimal notation and you just stop thinking in dotted decimal, the CIDR notation makes a hell of a lot more sense.
Yeah, it does, for sure. I was
All right.
happy when I learned it.
It's a struggle. It's a struggle.
Yep, it is.
But once you get there, it's good. The one that still I cannot get around is that what do they call it? Oh, it's not the subnet mask. It's the whatever it is that's in the inverse of that. I can't remember it. It'll come to me. All right, so we created our interfaces. So let's see our configuration. We've got our system, we've got our root authentication, and we've got our interface.
Is it a bitwise comparison? Is that what it's
It
called?
is, no, it's not that. It's a wildcard mask.
Oh, that's right. I got you.
Yeah, I knew it'd come to me. But yeah, so that part, I can't stand that one. That one's weird. So when you see a mask, it's like 000 dot, 0.254 or 16 or whatever the shit it is. I'm like, no, I'm good. I'll pass. Give me something that makes sense. All right, so Juniper devices, especially the SRXs, are always going to be security first. An interface will never talk unless you put it in a security zone. It will never talk unless you put it in a security zone, with an exception that is outside the scope of this. Well, our intention with the streams is that we're going to arrive at more complex configurations later. And in one of our more complex configurations, you'll see the scenario where my statement of security first and must be in a security zone has an exception. But we're not going to bother with that now. Don't look behind the curtain. All right, so we're going to go and create our security zone. So we set security zone, and we're going to call it WAN. Oh, you know what we forgot? Man. Set system host name. Always give your device a host name so you don't forget where the hell you are. So we're going to commit so that our prompt changes. So committing is the actual act of saving your config and putting it into active use. When you just go ahead and edit your configuration, what you're editing is what they call a candidate configuration. It is a non-active copy of your active configuration. So you can go ahead and make all of your changes and then use a single commit command to take all of your changes and then put them into service. So if you have a scenario where you're going to start changing some interfaces or changing some protocols or some firewall rules, you can make all of the changes to the configuration and have them all applied at one time. In addition to that, you also get the capability of what they call the commit confirmed. So you can commit, and then you start a timer where you have to make another commit to solidify your configuration. If the timer expires before you can make your commit, then it will automatically roll back your configuration. So the expectation is that if you could not make that commit for some reason, such as your changes prevented your access to the device, then the configuration will roll back at the end expiration of that timer. And the expectation is that you'll be able to get service restored. If there is a scenario where other things are at play, external things that prevent you from gaining access, obviously rolling back isn't going to resolve that. But if it's something as simple as an interface configuration changed and you don't have complicated protocols, then the device will become immediately available again.
It's
So
fantastic. It literally minimizes the pucker factor that you
absolutely,
would get in any other device.
yep. Going through and dealing with a Cisco Catalyst switch, and you're playing with some VLAN pruning, you make a mistake, and the lag unbundles, and now your device is not reachable. Or you need to change the IP address on the WAN interface of a router, and you're coming in from the outside. You change that interface, and now, boom, you no longer have access to the device.
Done. And then you get the phone call of shame.
Yep. Hey, can you go reboot the router? I know it's
Yep.
going to be out about 10 minutes.
Name drug through the mud.
Yeah. All right. So now you see we have root at left. So we are root at left now. So let's go ahead and let's set security zone, and we're going to call it WAN. So we're creating a security zone called WAN. And now we have to add an interface. So we're going to go interfaces and GE00, and this is where you have to use that dotted notation, so GE00.0. If you just specify the interface without the unit, it will not come online. You will not have associated the correct interface. So in addition to that, the Juniper has a configuration in their security zones called host inbound traffic. So this is the traffic that is destined for the device, toward the routing engine, toward the system itself. So these will be the protocols and other types of capabilities that the device itself provides or terminates, things like IPsec or GRE or ping, which is what we're going to set up. So system services, so this is a system service and it is ping. Other things that you would have under system services would be things like a DNS if you're going to be providing a non-authoritative DNS forwarder. FTP if you're going to run FTP, but I don't recommend you run these unsecure protocols like Telnet or FTP. Just about any system these days can do SCP, so do try to use that. SCP falls under SSH. There isn't a specific SCP protocol since SCP is just an extension of SSH itself. I think that's enough for now.
Sure. And I think, like you said, I mean, the Juniper being a security device, and it's essentially an implicit deny, right? So if you want it, you have to put it in.
Correct.
Which is great.
Correct. Yep. Security first. If you did not specify anything for host inbound traffic, the device itself would never actually receive that traffic that's destined for it. So you would send a ping and the device would just silently drop it. If you were going to set this device up to transit traffic, however, without host inbound traffic, you will still transit traffic. Traffic will still go from zone to zone. It just won't terminate at the device.
Okay.
So we're going to go ahead and create our ping. So now when we look at our configuration, you see our security zone WAN. Here is our system services ping. Here is our interface configuration. So we could create a policy, But remember, a policy is to go from zone to zone. We don't have two zones that we're dealing with. We could talk about the host inbound, not the host inbound, the Junos host zone,
Hmm.
but I think that's too advanced at this stage. There is a default implicit zone that you don't see, and it is called the Junos host zone. That is the zone that the routing engine, the devices processing actually happens. The the necessity of using that entirely depends on your use case. If you have a more complicated network, then you'll want to use that Junos host. And we will get to that in a later video. So right now, we should be good to go. Just looking over it again. We've got our system, we've got our root authentication. We created a host name so we don't get lost. We created a security zone WAN. We added ping, and we got the right interface. Here is the interface configuration. It is unit 0, which matches. We gave it a description just to be easy, and we gave it an IP address of 1.1, and it is a /24, which lines up with our diagram. And we're going to go ahead and we're just going to show you commit confirmed. So after commit confirmed, you can specify a timeout if you choose. If you do not, then it will default to 10 minutes. And we're going to go ahead, let's do 2. Let's do 2 minutes. So we're going to go ahead and do a commit confirmed 2 minutes. So now that
The nice thing is that commit confirmed, right? It'll keep notifying you. That is one nice thing, because if you completely forget, it's because you weren't. I don't want to say weren't paying attention, but I mean it'll notify you every time you hit enter, right?
oh, absolutely, absolutely, you can see that now. So anytime
Oh
I
yeah,
hit
yeah, there
enter,
you
it's
go.
going to show me right at the top, front and center. That doesn't mean you won't forget, but at least you can say,
You
well,
were
the device
warned.
definitely told me. Yep. Had I looked at it, I would have known. All right, so we're going to go ahead and make our second commits. And this configuration is complete. So we're going to go ahead and telnet into our next device. So we're going to telnet localhost, and this is 5002. All right, so here's our second device, and we see that we log in with root, and we go CLI. This always takes a little bit longer. And we go edits, and we go load override, terminal, and mash enter, control D, set system, root authentication, plain text password. Remember, it doesn't show you anything, including asterisks. And we're going to set system host name and rights. And we're just going to go ahead and commit now so that we can get our prompt all cleaned up and we know which device we're working on. This becomes more important as you're building out bigger networks and you're SSHing into multiple devices, because you're either provisioning a service or you're trying to troubleshoot a network. Always pay attention to the host name of the device and always set a host name. You never want to find yourself in a scenario where you've got 3 terminals open, none of them have a host name, and you just configured one of them with the configuration that should have been on the other one. And now you're back to either making the call of shame or the device, you're just sitting there waiting the next 10 minutes for it to roll back its configuration. And the entire time you're just sitting there, reprimanding yourself, stewing in your own juices, if you will.
Which also highlights the importance of having a good diagram to refer to, which you've
Absolutely.
created, you know, right there on the right in
Absolutely.
GNS3.
And there is no shame in that, even in the professional workplace, man. If having a piece of paper with some scribbles on it that define a network topology is what you need to succeed, nobody is going to criticize you for that.
Oh, oh.
The only criticism you're going to get is if you needed it and
and,
didn't use it,
and
or
absolutely, absolutely.
yeah, yeah. Nobody's going to give you shit if you drew a picture that saved them 3 hours of rebuilding the network or phone calls that had to be made.
Yeah.
Also,
And honestly, for the extra 15, 20 minutes, or however long it would actually take, it'll save that will pay for itself over and over and over and over.
Absolutely. Especially if something does go wrong and you need to, call for backup, having that diagram will make the troubleshooting process much, much faster. If I went and broke something and I got to call Jared and be like, Jared, I don't know what I did, but here's the network and here's what I'm doing. The troubleshooting can immediately begin. The questions can start going. You can start figuring out what went wrong or what the current state of things is, so that you can begin figuring out what went wrong. But
Yep.
without that diagram, you're just waving hands and using as descriptive words as you can,
Yep.
which
And
typically
if you
falls
have a
short.
bunch of devices, and if you have a bunch of devices, they're all the same model, even the serial number. I mean, for the diagrams, we draw up, we'll add serial numbers just so that it's serial number to serial number. If you have two devices alike, which one are we talking about? You can go by interface, but you know, um, even serial numbers are handy. That this device is the device I am talking about.
There you go.
So
You know, whatever you need to succeed. So, all right.
sweet.
So we've got our config. So we got our host name. We've got our root authentication. So let's go ahead and set our interfaces. And we are GE00.0. So you can use the short notation here if you choose. Now we're going to go ahead and skip the description. But in a production environment, definitely use descriptions. And address, and 192.168.1.2/24. And we're going to go create our security zone, and our security zone is WAN. Interfaces. We're going to go ahead and do that. We're going to do that just for you, Jared.
I was gonna say, I was gonna bring that up. The one thing that bit me is, it didn't bite me, right? Because it doesn't really matter. But when I was thinking about it, when I was building my first, very simple lab like this, I was under the assumption that that information, that security zone name, was essential that they matched. And then, obviously, as you carry that into a much larger network, you feel like you're naming everything the same, which would obviously muddy the waters or complicate things. Um, Really, what's important is that you know what the zone is. It does not cross devices, and that you pay attention to your how you wrote the security zone. So when you go to make your policies, it must match, or you are talking about a different security zone altogether, or one that doesn't even exist potentially.
Absolutely. And for any network admin or network engineer uh, getting into this field, there will be certain properties, there will be certain numbers, there will be certain names that are transitive, that are communicated. Device A does share this information with device B. There are unique values that are device unique. There are values that are going to be more globally unique within your environment. Do make sure that you understand what those values are and how they get applied to things. Things like virtual chassis or switch clusters. These types of things are switch virtual chassis and device clusters. Once you put them into the virtual chassis or the cluster, they'll typically get an ID. That ID is what the MAC addresses will typically be generated off of. So if you have a virtual switch chassis and you have 3 of them in one space, in one building, in one facility, or one campus, and they're all connected to each other, sharing the same layer 2 network and domains, the same layer 2 domains, if they all have the same ID, they will all have the same MAC address. This is one of
Oh,
those
okay.
values that, while it is device unique, and it needs to be something that's specific to that device, and it's not necessarily a transitive property, it's not something that's shared with another, but they do have to be unique within an environment, unique within the layer 2 domain that they share. If they never have, the layer 2 domains, they never touch, because they're separated by the internet, something like that becomes irrelevant what that chassis, that virtual chassis number is. And again, the only time it really pops up is if you've got them all on the same campus or in the same building. This is also true with Cisco devices. Things like a Cisco VSS stack or a Cisco switch stack, they will have a specific ID. The VSS, the VSS pair, the 4000 series, the 4500X, the 4500Es, they will have a specific ID with them, and that ID was what the Macs will be built off of. I think other ones, like the cat switch stacks, I think they use the MAC address of some device, but I'm not 100% on that. I've been out of Cisco for a few years, but the important thing is to understand that some of those values that you do set matter, even though they aren't communicated with other devices exchanged via routing protocols. So understand what numbers you've got going on and what their significance is locally, device, and globally within your environment. So
Absolutely.
you'll start realizing that there's a lot of numbers and things that you have to track when you start getting into some of these networking fields and some of these bigger networks. So documentation is important. Nobody likes doing it. I absolutely loathe doing it. So find yourself really good tools, good, easy tools that you will use. I've used Netbox. Netbox is very good. It's an open source product. Definitely check it out. Others use like Infoblox. Infoblox will help manage a lot of those numbers too. And at the very least, track them in a spreadsheet if you have to, if you don't have the ability to spin up any of these types of bigger services. But track the numbers, track your IP addresses, track your, you probably don't need to track MAC addresses, but other configured values that you've set up in these devices. So it's a pain in the ass getting it set up, and it's a pain in the ass keeping it up to date, but it will save you. It's worth it.
Yep. The one time not to be lazy.
Yes. All right, so we're going to go show compare just to see what we've got going on, and you can see that we definitely created some configuration. All of these plus signs mean that my candidate configuration has these things that my active configuration does not. So technically what we've got is show the candidate configuration and compare it to the implied candidate configuration, not candidate, active configuration. However, we can do something like comparing it to a rollback configuration, and we could say rollback 1. So this is what we have compared to one of the configs ago. So we're going to go ahead and commit this, and we're going to switch back over to left. All right, so we're on left, and in Juniper, if you are in the config mode and you want to run something from the operational or exec mode, you use the run command. This is the comparable to Cisco's do command. So we're going to go run, show, interfaces, and instead of brief like you would do with a Cisco device, we're going to do terse. So here is show interfaces terse. We've got some interfaces. I don't know what all of these interfaces do. You are welcome to Google them. FXP0 is that management interface. This is intended to be a non-routable interface. I don't even know if we can route it. Let's see. Where is GE?
Is the
All right. So we'll come back to that, and I will show you what we've got going on there. All right, so show compare. So you see what's missing here? So you remember we were talking about DPDK? So here is the VSRX DPDK. So this is uh, the actual packet processing engine. For whatever reason, this one has the packet processing engine loaded and it shows that it's operating properly, but I don't understand why it's not here. So what we need to do is we need to exit out. We don't need to run. We are going to request system reboot. In Juniper, you do not perform a reboot. You request that the routing engine perform a reboot. You request that the routing engine perform a reboot. This lines up previously, like I said, where the configuration is always consistent. If you have one routing engine, you still do a request. If you have two routing engines, then you are making a request to the routing engine to perform a action. You can request the secondary or non-active routing engine to perform an action as well. So you can do request system reboot, and you can specify which routing engine, which node needs to be rebooted. You can do the same with their switching stacks, their virtual chassis clusters. So there we go. DPDK, I don't know what happened to it. All right, so back to where we were. So show interfaces terse, and you will see that we have GE000. So here's GE00. This is your physical interface. So this shows link up. This is your logical interface. This is handling your protocols. It also shows up, so that's a good thing. That's a good thing.
Yep.
You can have a scenario. You can have a scenario where your physical interface is down, admin down, and your GE00 will show up. So we can go set interfaces GE00 and we can go disable. Slowly, slowly, slowly.
The commit can sometimes feel like it's forever.
Yes, and it does vary depending on the piece of equipment that you're working on. The SRX 300s and the 300 series devices, their storage is extremely slow, and these commits will take forever. So definitely be patient. If you're running automation, things like Ansible, you will have to adjust your timers. So anybody who's trying to automate an SRX 300 platform device, you need to adjust those timeouts. Your SSH session to the device through Ansible will terminate because of a timeout before your device actually completes the commit. So now we go run show interfaces terse. And we see that this is admin down, the link is down, the interface is admin up, and this will show down. You need to be paying attention to some of these because you could be spending a lot of time troubleshooting this interface just to realize that, oh, yeah, it is up, the link is down. Why is that? Because the physical interface, the parent to it, is admin down. The reason I bring this up is because I have done this. I have spent hours trying to figure out why I couldn't get this damn interface to come up just to find out that it's down. And it was configured to be so. So I did that.
Did you let the user on the other end know that?
Absolutely not. Absolutely.
It was something else, right? It was a much
Yep.
more deeper part of the config that was just lost in translation.
Yep.
And
It was one of the junior engineers. I don't know where he came from, but we will be taking care of it immediately, sir. I am so sorry.
Absolutely.
It would never happen again. Never happen again.
He doesn't even work here anymore. It's embarrassing. This is not the first time we found it.
Yeah. All right. So this is a great opportunity for another wonderful command. So we've gone ahead and we've made a configuration change, and we don't want that change. So we're going to go ahead and we're going to do rollback. So now the rollback command is going to do a rollback to a previous configuration. Your rollback 0 is always your active configuration. Rollback 1 will be one commit ago. So we're going to go rollback 1. So now we're going to go show interfaces, and we see that GE000 is no longer disabled. So we're going to go ahead and we're going to commit. Let's see how left is doing. Left is still booting.
Still doing its thing.
Yep. It'll do that for a little bit. Give me 1 second. I need some water, man. All right. For anybody enjoying the music, we're listening to Stream Beats. We're listening to the 100 Thieves music. Stream Beats. We're not sponsored. But Harris, if you want to sponsor us. Just saying. Otherwise, we'll continue to enjoy your music.
One thing, so we've went over the commit, we've went over the commit confirmed. If you're copying and pasting one config from one device into another, or just maybe taking or parsing out part of a configuration that you want to use in a device, whether you're copying a security zone or whatever, there is the commit check, correct? In case you missed a bracket or something like that, you can actually check that before you even try to do a commit confirmed or commit, correct?
Correct. Some of the things like missing a brackets here and there, those will get caught by the syntax processing when you're trying to load the command. Some other things will not, though. Perfectly legit, perfectly solid configuration that may have mutual exclusivity rules against it. Like you can't configure, 2 different versions of OSPF on the same interface. You can't do 2 different encapsulations that conflict with each other, or an encapsulation and a protocol family. Commit check will see some of those and then start changing, or I shouldn't say changing. It will warn you about those mutually exclusive configuration elements, telling you that you can't do this because you did that, or you can't do this yet because you need to do that first, or this needs to be done before we can commit. Those types of things, like this. So if we did a delete system root authentication, right now our configuration is rock solid, perfectly fine. But if we go for a commit check, it will tell us that we are missing something and we cannot commit because of it. So commit check is going to go run through the configuration, and it's going to tell me that I have a missing mandatory statement, root authentication. So we can go ahead and do rollback because we don't really want to do that. And rollback will load the active configuration, so we can go back to show system, and we see that our root authentication is back. For anybody in the Cisco world, you know that some things cannot be copied and pasted. However, this $6 password can be copied and pasted between 2 devices. So I can go ahead and paste this between all of my devices. Why is this significant? This is significant for anybody who's tried to remain secure and save their configurations at the same time. This password cannot be reversed. So this is safe for you to save in your your configuration repositories or whatever automation tools you've got, or even as templates. This can be put into your template and then handled accordingly for any of your engineers, junior admins, anything like that. They can hold on to this, and they have this password, and they can put that into each of their devices as they go. This isn't a plain text password written to disk. Never do that. Or at least try not to.
Very good.
I don't even know if you can make that plain text. You'll also notice that when we put it in, we did root authentication plain text password. What that means is I'm going to do a plain text password entry, and I'm going to enter the password on the command line. You can't actually put in an unencrypted password on that line, even through a configuration statement. I don't believe. I've never tried it, but again, it's bad business. You don't want to put a password in on the command line. Most of the devices will also log all of the commands. So if you were to put it all into the command line in one single long line, it has the potential of finding itself in your logs. And then if you're doing syslog, now you've shipped that off to your syslog collector, and now it's going into your backups and your archives, and your audit team is looking at it, things that they shouldn't see. Bad news. Bad news. But set system. Let's see. Nope, that's not it. I don't think that's it either. No. All right, no problem. No big deal. It's not something we wanted to do anyways. I didn't make any changes, right? No, okay.
Nope.
All right, left. All right, so it has a configuration on it, so we have to type in our password. It's preferred to type in your password correctly.
Oh.
You should at least do it once. All right,
there we are.
Wasn't ready to cover the password recovery yet. So Juniper devices, if you actually get them out in the field, they do support encrypted configurations leveraging the TPM on the SRX platform. I believe all of the SRXs have a TPM. Definitely check your device and make sure that it does. There are also recovery options that you can set within the configuration to disable things like password recovery. So if somebody does have access to the device physically and they want to try to do a password recovery maliciously or otherwise, instead of actually allowing you to do a password recovery, what it will do is clear the configuration and return it to a vanilla state. This is definitely a complication if you're trying to recover a device in place. The trade-off is security. You don't provide anybody the opportunity to gain access to your configuration or modify your configuration and put it back into production. If the configuration is wiped during a quote password recovery, then the configuration that you had on the device is no longer there. So the device can't come into your network if you were operating something like IPsec. You would then have to load the configuration that was saved by your network tools, or you'd have to write a new configuration from scratch. But that trade-off of security is there, and it's something that you have to consider with all things. Where there's more security, you also have a reduction in things like availability or the simplicity. The security always adds additional elements that must be considered in your environment. I do try to err on the side of security where all things can be. There are considerations that have to be made, but this is one of those that I put into place, making sure that a password recovery results in a configuration erasure, but making sure that you have the configuration prior to going there, or prior to being on site, or prior to making the call, and knowing how to recover that configuration if necessary.
Sure. Almost like an insurance policy, right? You hope you never
Yeah.
use it. You hope it
Exactly.
never actually comes into play, but the one time it does, it'll be worth having.
Exactly. We could even push this out to a scenario of, a completely, unintentional mistake. Somebody goes and they're like, yeah, Jared, this piece of equipment, we're not going to use it anymore. Just go ahead and dispose of it. So Jared goes ahead and disposes of it. But the device still had a live and active configuration on it. Somebody goes and dumpster dives at this Fortune 500 company that Jared works at, and they pull out this device and they're like, oh hey, look, this thing looks in pretty good shape. I'm going to take it home. Or maybe your janitorial services, or maybe one of your junior guys wants to build up a lab, so he brings it home. He does a password recovery. Now he's got an active configuration with potentially live IPsec configuration. If you failed to remove that IPsec configuration from your VPN concentrators or whatever VPN endpoints I was establishing, Jared or whoever could bring that device, put it up on their network, it could establish IPsec, and now you're on the corporate network from somewhere you should not be, that may or may not be tracked properly, and you now have an immediate active insider threat opportunity. This is
Absolutely.
obviously never an acceptable option. So
Yep.
having that last ditch fail safe option is always good.
Sure. And if you're talking about something small, right? And just like you said, a Fortune 500 company, when you have a team of people, it's not just going to be, Jeremy looking out for everything or everybody. As easy as doing an equipment refresh. You ship them out a new piece of equipment, they take out the old one, they put in the new one, and the other one gets tossed aside. No one really thinks of it, and now you've
Yep.
just given the keys to the kingdom away.
Yep. 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 Exactly. Exactly. All right. So left is now booted up, DPDK loaded properly, and we have an interface. So now that we've got our configuration all solid, and we see our configuration is there, hooray, we can go ahead and do our ping 168.1.2. And if everything's configured properly, we have
Hey,
traffic.
hey, hey.
Always those first pings will have a high latency. That's all due to ARP. But you see that the devices have come online. So that concludes this configuration. Hopefully you learned something, and stay tuned for future videos where we're going to take this same configuration and we're going to build it bigger. We're going to do it more. We're going to turn it up to 11. Thank you, and
Perfect.
take it easy.
Thank you.